All right. Now, back to a phase. In a phase, we need to talk about it in terms of states. In science class, a phase is just a state of matter. So, if it's a state of matter, what are the states of matter? Can anybody tell me that?
Yeah.
Yeah, what are they?
Solids, liquids, and gases. All
right, so the phases we're going to talk about are solids, liquids, and gases.
I thought it was like a fourth one or something.
Well, plasma is the fourth one, but we will not talk about plasma at all. It's not part of our curriculum. We are never going to talk about it.
What's plasma?
No one ever talks about plasma.
No,
what's plasma.
It's not part of our curriculum.
So wait, is it not important? Because we never talked about it.
What is plasma?
I guess not.
Shut up. I'm curious.
What's plasma?
The sun. Stars. Now, what is a phase change then? This is why I said if you were familiar with the water cycle, this topic should not be that difficult. So what is a phase change?
Matter.
Okay, freezing is an example of a phase change. That's an example. So what happens when you freeze or you melt? You change from what to what? All right, so you're changing from one state to another. Okay, so a phase change is when you change from one state to another.
Guess what?
What?
I was in Charlotte, and I went to this really ghetto gas station, right? And my change, I was supposed to get 50 cents back, right? I got a Chuck E. Cheese token and a Chinese like coin. I don't even know. It might be Korean. It might be Korean. I don't even know. But look, I think it's worth $1. So I'm just playing. Hey, bro, but I got you though. I just forgot. My bad.
I swear to God, if you give me that.
Huh? You want it?
If you give me like, no.
What if it's worth?
At least it's worth more than a Chuck E. Cheese.
What if it's worth like $100 and we don't even know?
You ever heard of it? I've seen it. Yeah. I'm
gonna look it up later. Bro.
No.
This might be a comment for real.
So what's needed for a phase change to occur? Now, this is the piece that I'm going to try to drill in your heads for 2 days. All right? In order for a phase change to occur, heat has to be absorbed or released. Now, the answer that most of you are going to give me time and time again, and you're going to pick on the test, is what? What do you think people want to tell me? In order for a phase change to occur, what do you think everybody wants to tell me we need? Well, that would be the great answer. If you would even say heat, I'd be happy. Most of the time they tell me we need a temperature change. Okay? And we don't have to have a temperature change in order for a phase change to occur. Okay? We just need heat to be absorbed or released. Now, we're going to look at this in terms of a graph. Now, usually at this point, I would start talking about the phase changes, except that, now it says 4 or 6. I'm going to change this to 4 because the state changed it a couple of years ago and took out 2 of the phase changes for y'all. In chemistry, I teach 6. In physical science, I teach 4. So, since they took 2 out, I'm not going to teach the extra 2. All right, normally I would start talking about the 4 phase changes here. But today I'm going to try something completely different. I'm going to jump over the 4 phase changes, and I'm going to do the graph first and see if it helps us at all. It can't go worse than it does every year. Okay? It can't go worse. It just can't. I'm sure. All right. Draw this and draw it fairly large on your paper because I'm going to write on this graph. Okay? Yep. Yeah, you can write 4 phase changes. This graph is a phase change graph. Yeah. And make it pretty big.
can't see.
Take one.
I'm trying.
It's
I was
different.
gonna take two. I wouldn't do that.
I'm gonna
to
put
you.
the tissues away. Secondly, people, tissues are not to dry your hands. Okay?
No, I'm using it to clean the Chinese coin.
It's not to clean a coin either.
How do I figure out what coin this is? Do I just look up Chinese
Look it
man?
up.
Chinese man wearing a hat, like on.
Try Googling it. Yes.
Look, bro. Look at this.
Take a picture of it and put the picture in the search.
Oh yeah, like take like the Google Glass.
Hey, I'm gonna try to look like this when I'm 80 though. You wanna see it? He got a long beard, bro. He look like he gotta do some kung fu moves or something.
Yeah, it looks fabulous.
Right, bro.
Well, let me see it.
But I'm gonna grow a beard like that. Crazy.
Now,
Who, me?
so that it makes it a little easier to refer to the sections.
Don't take it if it's worth like $100.
All right, we're going to label the sections A, B, C, D, E,
Probably like a penny.
just so it makes it a little easier to refer to them all. All right, while we're talking. Now,
It ain't come up. You're on counterfeit.
it's entirely possible. Who knows? Could be a children's coin for all we know. Maybe there's another one out there like Chuck E. Cheese, but it's in China.
But I can't believe he gave me a Chuck E. Cheese coin. Bro.
Now,
That's crazy. I hate the
there are 3 states of matter, right? All 3 states of matter are illustrated on the graph. A is a solid. C is the liquid. And E is the gas. Okay? A is a solid. C is the liquid. E is the gas. Are you with me on that?
Mm-hmm.
All right.
I'm gonna tape him to my notebook. Call him Mr. Wayne. Lucky. I get some tape. Yeah.
No.
Why?
Sam.
Tape him to my. I'll tape him later. Y'all gonna see him right there.
Now, as a solid, all right, somewhere back in your science background, somebody taught you that the particles look like this, right?
Yeah, I think so.
Okay. So as we go towards a liquid, and from a liquid to a gas, we're going to warm those particles, right? So if we go up the graph, we have to heat them, right? Would everybody be okay with that?
Yeah.
If we start as a gas and we go backwards, what would we have to do to go this direction? We would have to cool them. Everybody okay with that? So, if I start as a gas, the gas particles would be all over the place, right? They'd be all spread out. The liquid particles would be how? How would they look?
Like close together, kind of.
Like pretty close together. They'd be pretty close together. They wouldn't be orderly like the solid, but they'd be pretty close together. Okay? But they'd be pretty close. So,
Oh, yeah, I remember it.
What about solid?
all right, that's the solid right there.
Yeah.
I knew I couldn't fit it in that space. That's why I drew it down here. So, if I start as a solid and I warm it up to become a liquid, what phase change happens when I start as a solid and I warm up to become a liquid? What happens to me if I'm a solid and I change to a liquid? Okay, so if I'm a solid and I get heated up and I change it to a liquid, I did what? It's a word. I melt. Okay, so right here at B, and right above it, I can't fit it in that space. Right here at B,
Oh, you mean like something like that?
I'm melting. All right, so right there at B, I'm melting. Now, if I had come the other direction down the graph, and I was starting as a liquid, and I cooled down and changed into the solid, what would I do if I was a liquid and I cooled and I changed into the solid? I would freeze. So at B, I could also be freezing. Okay? Now, a really snazzy scientific word for freezing and melting that you may hear as is solidification. Means you turn into a solid. Okay? That's a really fancy word for you to turn into a solid.
What's the fancy word for melting?
Solidification, freezing and solidification are the same. I don't really have one. All right, so if we keep going up the scale on the graph, and we're a liquid, all right, what do we call a liquid when we change into a gas because we got warm enough? What? Evaporation. All right, so with D, we can evaporate. Okay? Now, we can also do what if the temperature is high enough? It's another word that's a little higher than evaporate. Starts with a B.
Is the word a B? I know it's a word, but
It's a higher temperature than evaporate.
boiling.
We're going to talk about how, evaporation and boiling are different. Okay? Because they're not the same.
It don't get evaporated as you boil it?
It can evaporate before it boils, yes. Okay? But for example, what do you see when it boils that you don't see when it evaporates?
Bubbles.
Bubbles. Okay?
Well, if it goes up, you can see the bubbles that gets like or whatever it is.
Stop so I can hear what Nigel's saying. What'd you say?
Like when you're boiling something, like water,
Yeah?
and when the smoke come up,
That's steam.
it's like it's stuck on the microwave.
Yeah?
What is that called?
That's just steam.
How does it get stuck if it's evaporated already?
Well, evaporation takes place at a lower temperature than boiling does. Okay? Bubbles you see when it boils. You don't see bubbles when it evaporates. Boiling takes place at a higher temperature than evaporation. There's about 5 different things we can look for to know something's boiling versus evaporation. Okay? And there, once we talk about them, you'll be like, oh, yeah, that's pretty obvious as well. That's a no-brainer. Okay?
We should do a lab butt cooking.
All right, now, if we come down the scale, if we start as a gas and we cool to a liquid, what do we call it? If we start as a gas and we cool to a liquid, nope, freezing's down here from a liquid to a solid. We're a gas and we change into a liquid.
How do you say it?
We're condensating. So it's called condensation.
I understand that for good.
Okay? Now, I just didn't hear you. Jose, put the stool. Where you hit somebody in the head accidentally. And then I have to explain to someone how you hit someone in the head with a stool.
Damage.
You could just not tell me.
Some of them have come
That's
loose.
a lot of damage.
Okay, here.
Now,
Next
we
slide.
need to talk about which of these are endo and exothermic. Okay? The ones that need to warm, okay, have to add heat. are endothermic. Okay, so which ones have to add heat? Which ones have to add heat, have to make the particles go faster? Endo.
What?
Look at your graph. Which ones need to add the heat to make the particles move faster? Do we need to add heat to melt or to freeze? To melt. So melting is endothermic. All right, so now move to the next phase change. Do we need to add heat to boil and evaporate, or do we need to add heat to condense? Which one needs the particles to go faster?
Evaporate.
We need it to evaporate and to boil. Okay? Now, if those processes are endothermic, what does that mean about exothermic? Which ones are going to be exothermic and remove heat? Okay. The ones that have to cool down, right? So the ones that the particles have to slow down. Whose particles have to slow down and get closer together?
Oh, wait, no, I can see it on the laptop.
Okay. Who has to slow down and get closer together? All right. I heard several people say the right answer. All right, so as you come down, freezing or melting, who has to get closer together? Freezing and condensation. Now, tomorrow at some point late in the day, we're going to do a small mini lab to talk about endo and exothermic. So how is endothermic going to feel to the touch? Is endothermic going to feel cold to the touch or warm?
Cold.
Endothermic is going to feel cold to the touch. Okay? So tomorrow, you're going to have a couple different cups. And you're going to have to feel them with your hands. Nothing's going to burn you or freeze and stick to you or anything. But you're going to have to feel them to see if the temperature went up or if the temperature went down, okay? And you're going to have to see, oh, does it feel colder or does it feel warmer? Now, it's not endo or exothermic if you put it in the refrigerator and it gets colder. It's endothermic if you mix two things and it gets colder because you mix them and the chemical reaction caused it to get cold, okay? Exothermic is going to feel how? How's exothermic going to feel?
Hot.
This one will feel hot to the touch.
It become cold.
Okay? Huh? How do what work?
Refrigerators.
How do refrigerators work?
Yeah.
Well, they have a motor in there and a compressor that causes cold air to come out of them. But beyond that, I'm not a refrigerator mechanic. I don't work with HVAC, so I don't know.
Cold air.
Yeah, it's just cold air. Not that I'm aware of. But the idea behind them is the cold air causes the molecules inside to slow down. And by slowing them down, they get closer together. And so they have a lower temperature once they get slower. Okay? Anything that the motion slows down, their temperature goes down. So it's going to have a colder or lower temperature, which is going to cause it to feel colder to us.
Yes.
Okay?
Yes.
But how the principles of the motor and the refrigerator work, that I don't know.
Got insulation?
It has insulation in it. Yes, that's why the outside of the refrigerator is thicker so that it insulates it and keeps cold air in it once the refrigerator temperature goes down. it stays cold. That's why when you lose power, what should you not do to the refrigerator?
Open it.
Open it, because you want to keep that cold air in there as long as you can.
Yeah.
Okay?
Makes sense.
All right, everybody with me so far?
Yeah.
All right, so we've done all those. Now we need to go back and pick up
We do a quick
this.
later.
No, we need this. All right, so how are, I need it here. Let me do this. There. That's where we need to be at. All right, so how are evaporation and boiling different? The only thing I think I've missed so far. All right, how are evaporation and boiling similar and different? We're going to do the similar first because that's an easy one. All right, and I already have the answer up there because I got rid of the crap we didn't need. All right, evaporation and boiling are similar because they both change from a what to a what? They both change from a liquid to a gas. But we want to talk about how they're different. All right, we've already done a little bit of that.
I didn't be messaging you this long.
Huh?
They need to leave me alone, bro.
Who does?
Everybody. You
I don't know why they're bothering you.
sending me memes, bro. Nobody want to look at that. It's not even funny anymore.
All right, everybody caught up?
Yep.
All right, so how are evaporation and boiling different? All right, I just did this in a chart. I don't care how you do it. I put 5 things in here that are different. All right, one we've already done. What did we say evaporation had? That boiling has and evaporation doesn't, is the way we said it. Boiling had what? Boiling had bubbles. So on this side, I put bubbles. And on the evaporation side, I said no bubbles. I don't know where it is in my chart, though. All right, so on this side, write bubbles. On this side, write no bubbles. It's on there somewhere. I just don't know where. All right, but we've already done that one. All right, tell me this. Where do we heat when we want to boil something?
Stove.
Okay, so it's on the stove. So it's where? It's on the bottom. Okay, so for boiling, we heat from the bottom. When something evaporates, where do we heat from? Usually from where? The sun or maybe some light bulbs or something in the room. But we heat from the top. Okay? All right. So what temperature does water boil at? Because most of us would think about water. 212 is on what scale? Fahrenheit. Can anybody tell me the Celsius temperature? 100. So that's how many different temperatures for water to boil at? 1. Well, 2 if you count the 2 scales. But it boils at 1 temperature, right? How many temperatures does water evaporate at? A lot of them. I mean, right now it's 68 degrees outside. In here, it's probably around 70. Yesterday outside, it was in the 60s. Next week, all week it's supposed to be in the 50s. Last week, it was in the 40s. Would water, if it rained outside, would it dry on the roads? Eventually. I mean, but this week, today, it's going to dry faster because it's in the 60s than it would last week in the 40s. But do the roads dry? Eventually, they dry. So my point is, when it evaporates, it dries at any number of temperatures. Boiling happens at what temperature? 1 temperature. Okay? So evaporation happens at many temperatures. Boiling happens at 1 temperature. That make sense?
Mm-hmm.
Okay. I don't know what I have next.
What else?
I have most of the science ones at the top. All right. Evaporation only happens at a particular place. Evaporation only happens at the surface of the liquid. The boiling happens throughout the liquid, which is why we see what when we boil? That's why you see the bubbles. Okay? The bubbles are what's indicating that it's happening throughout the liquid. All right? Evaporation only takes place at the surface of the liquid, which is another reason it takes forever for things to evaporate, because it only happens from the surface down. All right? This is the one we already talked about. Heat's added from the top, heat's added from the bottom, bubbles and no bubbles. And the last one is sort of a no-brainer, because this happens at all kinds of temperatures. The particles are slower. This happens at a higher temperature. Particles are going to be faster.
Is there any way to see particles?
If you're looking at water, you can see all kinds of particles. Right?
What? Yeah.
All right, this should take about 5 minutes or less. This is really quick.
Is it a grade?
Nope. Mario Diabian, this is in y'all's row. Tyler, this is in y'all's row.
We should use this as a test. We're doing it now?
Yeah, you're doing it.
Good.
Doing it right now.
Well,
Yeah.
did you fix that? I was here.
Yeah, I think I did.
We going over this?
Uh-huh.
Good, because some of them confusing me. Just a little bit though.
There you go.
Yep.
No. Any questions? There we go. How do I add another question? All right, stupid thing. I need one more question. There we go. Done. Okay. That should be good. That should be good. We should be good. All right. I should have what I need. All right. All right. So if we look at the questions, where's the paper? Question 1. All right, number 1. What's the freezing point? All right, and that's for the freezing point. Does it want a letter? What's a number? Okay, so take your, those of you said B, go across and give me a number. 5 degrees what?
Celsius.
All right, 5 degrees Celsius. All right, for the boiling point, you did the same thing, find the number. 15 degrees Celsius. All right, number 3. 5 degrees Celsius. Everybody good on 1, 2, and 3? All right, the next one says what letter? All right, so what letter range is the solid warm? A. The letter A is where it's warm. Now, notice when it says warm. What do you notice about the graph when it says warm? What does the graph have to do to be warm? Has to go up, okay? The graph has to go up to be warm. If it said what letter has to be cooled, what would the graph have to do? Have to go down, okay? Notice this also. What do you notice about all the phase changes? The phase changes have to be what on the graph? Are they going up or are they flat? They're flat spots. All the phase changes, boiling, melting, freezing, condensation, they're all flat spots. What did I tell you had to be added or removed? Heat. Does the temperature change during a phase change? Temperature doesn't change. When it freezes and melts, it does it at the same temperature. It does it at 5. That stays flat. Temperature doesn't change. Okay? So, what letter represents where a solid is warm? The solid is at A. and it goes up. That's where it's warm, so the solid's an A. What letter is the liquid? The liquid's not D. The liquid is C. Liquid is at C. And where's the gas? Or the vapor? It doesn't matter if it says vapor or gas. It's the same thing. The vapor is E. Okay, so A, C, and E. Liquid is A. Sorry, solid is A. Liquid is C. And the vapor is E. All right, what letter represents melting? B is in boy. All right, vaporization. D is in dog. All right, I'm going to flip the order of 9 and 10. All right, what does kinetic energy mean? It's moving. All right, so what changes kinetic energy? Temperature. All right, very good. Surprised yourself there, didn't you? All right, so temperature changes kinetic energy. So where is kinetic energy and temperature changing on the graph? All right, so A, C, and E are changing in number 10. Okay, so number 10 is A, C, and E because that's where temperature's changing. All right, so now go back to 9. So where's potential energy going to change? B and D. Does that make sense?
Yeah.
All right, so number 11. What represents condensation? D is in dog. What represents crystallization? Can't be A because A is not a phase change. B is in boy. Okay? Which one was which one? 10 is kinetic energy. Where's the temperature changing on the graph? A, E, and C. No. All right, we're going to do plickers for the last part of class. I got to add Luis. Oh.
Do we have to?
Yes, we have to. Stop blinding. Yeah, you can get some water. Hey, we can take more notes.
All right, bet. No. I'll do
I thought you might see it my way.
it.
I'd rather say that.
How about you see it my way and we don't do nothing?
No.
I like his way though.
I don't like his way.
What? I should teach again.
Packing up. Can we pack up? We're just on do plickers, right?
Yeah, you can pack up because we're just going to do plickers.
All right, cool. You want your big mistake? What big mistake?
All right, we got to add Luis.
Ah. Do the just
Mine ain't even here.
it's a lot of work. Oh, all right.
I was about to say, you see the back?
Someone took mine.
How do I spell it? C-R-U-Z-M-E.
Mario, hand me 3.
M-E-S-A, M-E-Z-A.
ZA.
Z-A?
Someone took mine.
Did you do it?
What, y'all do it?
Yeah.
A little bit.
Okay.
Najee, what's your number? Huh? What's your number?
Luis, you're number 19.
So what you can get it?
Give me your cards.
Najee.
Hurry up. We're not going to do a lot of these. Put the meter stick back.
What's that kid? What's it?
It doesn't have to be back there. I used to second period to point stuff.
Why?
We're supposed to have one over there that's repurposed somewhere else. Tyler. Move where you're supposed to be.
Doing it now?
Yep.
Why this smells?
Yeah, we cook every Thursday. I need to say something.
Miss Wall,
Yes,
can I have Diavion McClure,
yes,
McLeod?
yes.
Thank you.
You're welcome.
I tell him every time he thinks that.
All right, everybody got question? Please answer. Ready? Take the hat off.
You disrespecting me? I'm outside.
They don't wear it in the building.
Soldiers are bald.
You don't wear it in the building. That's why she doesn't have it on in the building.
There's two answers. What? What?
Didn't get me.
I don't think it is. There you go. Oh no. Here. Will we go over them?
Yeah, in a minute.
Did you get this?
All right, so
Oh, what?
Trevor's absent, Jose. All right, Joseph doesn't play. We should be good. All right. All right, so the answer is a high specific heat means you will heat and cool slowly. All right.
Oh,
Here, this should be an easy one.
I need to read the question.
You got it wrong.
This should be an easy one.
I knew.
Whatever. I usually keep losing.
Thank you.
Always
You said it's easy. Watch me get it wrong.
Wrong, it was the. I saw you could see. I'm pretty sure I'm right.
All right.
What is this? This is
That's A.
Hey.
Oh, I got it right. Oh, I put D.
Really, that's good.
I got a whole lot of cold warms and ups.
Miss Wall,
Yes,
Elizabeth Alvarez, Pepper,
yes.
Lady.
Okay.
That's nice. I'm trying to leak too. While you go home.
I'll take you to.
Hey, no. Really?
I will listen to it.
Really? Put your card on my desk. Have a nice day, dear.
Okay.
Not you.
What was this?
That's how you say Miss Wall.
Is it touching the pot or not touching the pot?
Doesn't appear, Vic.
Scan it.
Your fingernails are black.
I mean, if I get it wrong.
What is that?
The answer is heat.
Wait.
Can we
If your hand's in the black, it will not scan. Doesn't matter how long you hold it in front of my phone. Yeah, see, your finger's in front of it.
I already scanned it.
So, that should be everybody. Okay, radiation.
Convection.
Big
First one
surprise.
I got right.
Can't you see
Be
the
surprised.
I can't, I have to go to a different screen.
Bro, what?
what letter represents conversation?
Oh my
Yeah.
god, dang. Oh,
I can't see none of that.
What's condensation?
Wait, hold up.
Yes, I have lots of people that got them wrong.
he said.
Did I get it wrong?
Also, you saw the answers.
Comes up red on the screen. I know immediately when you've got it right or wrong. All right, condensation is the flat spot. It has to be BD. DC is melting and freezing.
But they get it.
CD is a liquid.
What did I get? DD, right?
Yeah, they just guessed. All right, last one.
Last one, here we go.
Last one.
What's happening?
Who puts their hand on that thing? You're dumb.
Can't fix stupid.
I do.
Let me
See how-
Where's Dean?
I'm gonna say one.
Y'all ready?
Hallelujah. We finally got one everybody got right. And I've only seen that twice, the only time I've done this.
I can see how people. That's a pop one.
So unorganized. I might be. Miss Wall, can
Yeah,
I stay here during lunch?
can you what?
Stay in here during lunch?
Yeah, I guess.
You guess. What happened to this one?